I'm Rick Stadler, President of Rattunde Corporation, and we're going to walk through the Rattunde ACS CFM Curve today for a little bit, point out some of the features that make this machine unique. The beginning of the system is the bundle magazine. The bundle magazine system for the Rattunde machine is unique to the industry. The controls involved in the machine, from centering of the tube to the sawing process to how we separate the tubes from the bundle into the pre-centering area, is very unique in the industry. Bundle magazine has a capacity of 5,000 kilograms, which is about 11,000 pounds. The straps raise up until the tubes are deposited onto the table. We can control exactly how many tubes we have on the table through a series of sensors. Once we have the required number of tubes on the table, we escape the tubes into a secondary section, and in this secondary section, through the alignment rollers, we're aligning the tube to the justification datum point, which is on the far right side, and this is the location where the tube needs to be picked up. The bundle magazine is capable of loading a single tube at a time for single cutting. We can load 2, 3, 4 tubes at a time for double, triple, or quadruple cutting, presenting the tubes in the perfect location to be picked up for cutting. Integrated into the bundle magazine is a sensor where we're able to pick up the tail end of the tube. This is very, very important when we want to minimize drop-offs, tag ends, and so forth. Reduces material usage. When the end of the tube passes the sensor, we very accurately detect the last end of that tube. The machine instantly calculates how many more cuts we can get out of that remaining tube. The process proceeds through, and with this we're able to have as little as a 30mm tag end. Next, we're going to walk over, we're going to show you the feed system of how we feed the tube into the sawing system. The next section of the Rattunde ACS CFM system is the feeding system. Very unique system again, where we take the tube from the bundle magazine area and we're moving the tube the required cut length through the saw. What's unique about the Rattunde system is that when we grab the tube with a pre-programmed pressure. We also detect the exact position of those clamps. So for instance, if we're feeding in and there happened to be some debris left on the material that would cause an out of square cut or something like this, we would detect that. The process would stop. You'd get a plain English display message on the screen saying, there's an issue with the clamping. Look at it, understand what's going on, clear the fault, and then continue on. As we're feeding the tube, we're constantly monitoring the pressure, which is also the force that we're clamping the tube with. We're always watching whether or not we are within the predefined parameters of the position of the clamps. If it's too big, we stop. If it's too small, we stop. The next step after the feeding process is going to be the sawing process. The sawing process is behind this panel. We're clamping the tube with the same idea that we use on the grip feed. We're clamping with a pre-programmed clamp pressure and clamping force. We're looking for those saw clamps to come to an exact position. Again, detecting the possibility of a chip, a bit of debris, any number of things. If the clamping situation is not exactly perfect, we won't make the cut. Assuming everything is good with the clamping position, the saw blade is going to travel down, it's going to rotate. The Rattunde sawing algorithm is also like none other in the industry. We're monitoring the amount of load on each and every tooth of the saw blade by calculating the feed rates, calculating the tensile strength of the material, how many teeth are engaged in the material at any given time. As we're beginning to cut through the top of the tube, we have more teeth engaged into the material for a tube, and we'll feed at a little slower rate. As we get to the middle of the tube, we have less teeth engaged. We'll feed at a faster rate. Then at the very bottom, where we have the most teeth engaged, we'll again slow down. What this allows us to do is to move the saw blade through the material as fast as possible, the most efficient way possible, giving us a good, clean, square cut and a burr-free condition. After cutting in the ACS CFM Curve, we have a robotic arm that unloads the part into our chamfering. The chamfering station on the ACS CFM Curve, again unique to the industry. The part is held in clamps, monitored for pressure, monitored for clamping position, so we're looking for any chips or debris or anything that could be in there that could again cause an out of square condition when we're machining. We'll detect that, we'll stop the process if everything is not perfect. If everything is perfect, the machining heads come in simultaneously from the left side and the right side, and we do our machining operation. The machining operation on the CFM Curve can be threading, it can be notching, it can be simple IDOD chamfer and face. We can do center drilling on solid bar parts. We can do curve machining where we go in and we define very complicated paths on the outside of the tube and on the inside of the tube for things like O-ring retainers, circlip retainers, things like this. Very easy programming, no G-code required. When you go to the screen, the customer is simply asked, how deep of a chamfer do you want to make? What's the angle of the chamfer that you want to make? How many threads do you want per inch? How deep do you want the threads? They're just simple questions that are answered. No need for complicated G-code. After the part's finished, it's transferred into 100% length inspection, which is just on the outside of the light blue section. The length tolerance of a machine part is plus or minus 0.05 millimeters at 1.67 CPK. Our standard deviation for length is generally around 0.02 millimeters. Very, very tight tolerances for very complex machining. All the parts are 100% checked for length. This data is stored in the computer that sits behind here for retrieval at any time. Every part ever made is stored in the database by date, by order number, by production run. This can be searched later to find out exactly what length was that part cut at, what saw blade torque was used to part that. After length inspection, we go to the step conveyor bridge. The step conveyor bridge is really a platform for secondary operations and secondary measurement. Let's open it up and take a look inside. The parts have come out of length measuring and are queued up in a 10-station platform. Each one of these stations can have any number of secondary operations or measurements, measurement devices added to it. We can weigh the part if you're cutting solid bar, which is important for the forging industry. We can add laser marking to mark the part on the outside with a logo, a part number, a serial number. We can do secondary operations such as notching, burr removal, secondary burr removal. The most common feature that is used on this is shown in the last station is TIR, or total indicator reading. From this, we're able to measure straightness of the part. We can use 3 lasers to do this. We could use 5 lasers to do this. We can also add lasers on the end and measure end squareness, so we can detect how our process is doing. If we have non-conforming products, we can immediately stop the machine, alert the operator through a screen, plain English message on the screen to say something's out of tolerance, check the setup on the machine, check your tooling, whatever you need to do to bring it back into tolerance. So from this point on, we know that we have 100% good parts. After we fed the part, cut the part, machined the part, inspected the part, we come to tertiary operations. A lot of customers at this point opt to put a washing and drying machine, which is built by Rattunde. The washing and drying machine is there to remove any chips left over from the sawing and machining process. to add a little bit of rust preventative element to the parts if they're to be stored for a little bit. The washing machine would come right after the step conveyor bridge, which we just talked about. Heated washing into heated drying. The parts come off. They are completely dried with a amount of rust preventative applied to it. Out of washing drying, we would typically come to what you see here is our inspection table. What this gives us is the opportunity to pick up parts, for the operator to hold them, to feel if there's any burr condition, to feel the surface. Just inspect the part and hold it in your hand before it goes into the next process. The next process is finished packaging. So last chance for the operator to take a look at this and verify that the part is indeed 100% compliant. After visual inspection, we go into our automatic packaging system. The automatic packaging system comes standard with a magnetic gripper, useful for carbon material or any ferritic material. Optionally, if you're cutting austenitic stainless or aluminum, the gripper or the robot arm can be fitted with suction cups. The robot picks up the required number of parts and places those parts in a bin of your choice. You simply tell the robot what size bin you have, how many rows you want to stack, and the system automatically figures out how many pieces it needs to grab. Not complicated in any way. You don't have to say, grab 3 parts this time, grab 2 parts next time. The robot always knows. It grabs the parts, it fills it up to finish, and again, optionally, which we don't have at the show today, we would have what we call our container changer, which is a roller conveyor that travels through the robot, moving empty containers in and full containers out.